Okay, hello, welcome, konnichiwa. Welcome to our new education video training. Today we focusing on the maintenance schedule. So that means we're going through the maintenance schedule here, all the different points here, step by step through this document, and focusing on each point. I had prepared already a folder which I will upload for you with all the different instruction documents in English, what we can use from Schnell. There's one document missing. I'm busy preparing to translate it into English because it's at the moment only available in German. But I'm busy on it, and I will support as soon as possible to you. So, yeah, what are our topics today? It's the maintenance schedule for the 6R21B, so B for biogas, TC, important TC because of the turbo compound. We go to the parameter at rating power, the idle operation check, the cool water system check, the charge air cooler system check, the whole engine, the turbo compound, exhaust gas system, CHP unit control, and gas system. Here's the list of the different documents, what I showed you before, and the list is part of the maintenance schedule here in the different head letters. So we have the 3 pages, and I always come back to that document and go through the points one by one. So, sorry for the interruption. I had to prepare my microphone against the wind noise. It's a little bit windy here. Okay, let's go further into the video and the program. We are focusing here on our parameter at rated power. That means that we can compare before maintenance and after maintenance all the values and see that the operation is something changed, or if we have focused on something more, what could be a problem, that we can check the system in advance to know what we have to do during the maintenance. So we have the operation value. We'll go through all the steps step by step. We have the different pressure of charge air cooler, the crankcase pressure, the exhaust gas values, the exhaust gas back pressure, the biogas quality, upstream of the cleaning system and downstream of the cleaning system. So let's go into deeper. First, we have here the engine operating values. That means we are talking about injection angle and injection pulse width. This two actually is the settings or the values on which position the pilot fuel get injected and how much get injected. So that's the timing and the amount of pilot fuel. I'll show you where we can find that. Then we have the charge at different pressure. So to analyze if we have any pressure drop or blockage in the charge air cooler. Then we have the exhaust gas values. So we usually focusing on O2 content, CO content in milligram, NOx in milligram or ppm, depends on what measurement tool we use. And then we have the back pressure, where we can measure the back pressure in the exhaust gas in millibar. And on the biogas fuel quality side, it's always important to have the exact details of the CH4, so the methane content in percent, the H2S, so sulfur content in ppm, and the NH3 ammonia content. So this is that's the operational values. That means know on which position, with what quality of gas, and with which exhaust gas values the CHP is currently operating before maintenance. Hey, I recommend to do always screenshots or a picture of the different menus in the visualization, so it's easier to record it, and easy to use it later on. So for example, if we log into the visualization program with our login password, then we can open the operating values. That's that button here. With that button we can open that window, and we see then the important values like the injector angle. For example, here it's 14.8 degrees, and the active pulse width, for example here, it's 690 microseconds. It's a very important value and give me some figures how the system operates. I add another value. What is, I think, very important is the charge air pressure. So the charge air pressure we will find here. This gives me a good indicator. These three values, I will do a separate video on exactly on that values, because these three values give me, or can give you, more details how the system actually is operating. Are we on an operation where we know we are on a limit of combustion, or we are in the usual ranges? So the other thing, the charge air cooler, we have different options on the charge air cooler. We have on the inlet and outlet option that we can put pressure gauges there. As well, you get measurement tools where you can measure the differential pressure between in and outlet. So usually we use millibar or kilopascal to measure the differential pressure, but we still have to keep in mind we operating, if you look on here, we operating on, for example, here at 250 kilowatt at 158 kilopascal. So 158 kilopascal is 1.58 bar. So the pressure gauge, what we use here to measure, must have a range or a maximum of at least 2 bar or 200 kilopascal to measure that properly. Here on the pictures we have pressure gauge of megapascal. You see that's why we start with 0.1 and so on. The differential pressure on the charge air intercooler should not be higher than 50 millibar or 5 kilopascal. So if we reach a value of 5 kilopascal, that will mean at the end of the day the charge air pressure at the engine will be of 5 kilopascal lower than in front of the charge air cooler, which means we losing pressure and we losing energy through the charge air cooler system from the turbocharger to the charge air cooler system into the engine. If the charge air pressure gets too low, we can get problems with the engine injection or combustion system, as we had sometimes already at Urimaku plant, where the charge air cooler got blocked, and then we have a high pressure drop and the engine cannot operate in the proper range or in the safe range. That's very, very important that we measure that always before we do the maintenance, that we know the status of the charge air cooler, or where we can see where is the pressure drop. Then the next point is that we have to focus on the exhaust gas values. So the exhaust gas values, we focus on O2, CO, NOx, and back pressure. In the visualization, we can see the NOx and the O2 and the status of the NOx sensor. So in case that we don't have external exhaust gas measurement tool to measure all that values, we should minimum record that values. I usually recommend that we use an external measurement tool because the external measurement tool is much more accurate than the sensor, internal sensor. So the internal sensor will be used for the control and works very well, but to compare, it's always good to have an external measurement tool that we can compare the values and see if there is a problem with the sensor as well. The back pressure must be measured separately with external measurement tool, either with the exhaust gas measurement tool or with a measurement tool that can directly measure the back pressure. We come to that later as well. The exhaust gas back pressure limitations. So if we have exhaust gas back pressure, it's less than 50 millibar, that's a very good conditions. So that means we don't have any problems on the exhaust gas system. So that means no problems of blockage or cloggage in the exhaust gas system, silencer, exhaust gas heat exchanger, and through all the piping. If the pressure goes up to 50 to 70 millibar, it's still okay if the rest of the operation of the CHP is still in the limits. Above 70 millibar, that's very bad. So a high back pressure forces a bad combustion of the engine and can force damages in the engine. So, okay, so to measure the gas quality, usual in most of the plants there is a gas analyzer installed, for example like that one, there's a SSM 6000 I think, there we can measure the methane content, the sulfur content, the O2 content, can that tool measure, and the CO2 content. For us it's important here the gas fuel quality. We have the CH4 methane content in percent, the H2S sulfur content in ppm, and the NH3 ammonia content in ppn. We have always the option, or always the other option, that we can measure, for example, the H2S and the NH3 content with this Traeger measurement tubes or something similar. So that important for the measurement tools, that we always have that for the right limits. Okay, let's go to the next page. So here we have the gas quality document for the gas content of Schnell CHP. So we have here the limitations, and here we see on the limitations we're talking about the H2S and the NH3 content. The limitation on the sulfur content is, so the H2S content on a dual fuel unit, so a dual fuel CHP. That means to the CHP, after the gas conditioner module or gas treatment system, to the CHP we should not exceed 40 ppm. This is for the gas genset or gas CHP of Schnell we need less than 15 ppm. Upstream, if you have your own gas treatment system, then the upstream is up to you. But if you only have active carbon filter in between, the upstream should not have a higher content of 200 ppm. Otherwise, the active carbon filter will be very quick full of H2S content and cannot filter anymore. And then you will get on the downstream to the CHP a higher ppm. So and you have to replace the active carbon. That means at the end of the day, the cost of maintenance will increase. The ammonia downstream limits is at 100 ppm, so we should have lower than 100 ppm. The ammonia can force knocking on in the combustion, and out of the knocking can force damages on the engine. The quality of the gas, especially the H2S, so the sulfur content, can have very bad impact on the engine or on the parts of the engine. So in case we have a high H2S sulfur content, it's very important to change the oil. So the point is, the H2S content have a big impact on the engine oil quality. So it's changed the quality of the oil. The viscosity of the oil get changed as well. It can get up to like jelly. So the quality of the oil change, and yeah, and losing lubrication. And the oil can get out of the H2S content very acidized. So the H2S have all the impact on the oil quality. So, and the oil quality can affect all non-ferrous metal, like for example here the friction bearing. So the friction bearing of the Conrad main bearing. A lot of parts in the engine. I have some pictures I will show you now. So the H2S content can damage, for example, here we can see the Conrad. We can see here the damages on the bearing, or actually that's the inside of the Conrad of the bearing. We can see here separate bearings, main bearings. You see all these spots. So the point is that actually the thin layers on the bearing, on the friction bearing, get eaten up, and that means you can see all the small spots. So then at the end of the day, the bearing get damaged, and if the bearing get damaged, we can get damages on the crankshaft and on all other Conrad parts in the engine, and at the end of the day it can cause an engine damage, because if the bearing is gone, the engine cannot work properly anymore. So the next thing is the impact on the charge air cooler. So the H2S can have a big impact on the charge air cooler. You can see the green bluey color change. That's one thing, is corrosion. So with a high condensate content and H2S, we can get corrosion of the copper elements in the charge air cooler. Through that we can get blockage and damage on the thin fins or the thin channels, and then this get blocked. So this must be focused on, that we always check the H2S, and in case we have a high H2S content, we have to look on our gas treatment system and try to ensure that we reduce the sulfur content from the gas. So high HS content, check the gas treatment system, replace the active carbon or whatever other filter system you use, or maybe you have you use oxygen in the biogas storage to reduce the H2S content. In this case, increase the amount of oxygen what get blowed into the gas storage. Focus on the gas treatment first, but on the same time have a look if the H2S content is quite high. Replace the engine oil. We saw on the previous slides that the engine oil get bad and get damaged from the H2S content. So in case of a high H2S content, I recommend immediately to replace the engine oil. If we still have a higher H2S content in the biogas and the system is still running, then you have to reduce the interval of the oil change, so that we always get the old oil out and fresh oil in, so that the quality of the oil stay on the high quality limit, so that we're not getting any damaging in the CHP. And in case, worst case scenario, the CH2 content is too high and we don't get it lower, we have to stop the engine. The H2S content will affect the quality of the oil and at the end of the day can force damaging on the engine, which is very, very expensive at the end. Okay, let's go to the next one. So we went through here all the parameters of rated power. So now let's check the parts immediately after engine is in idled. That means if we stop the engine and the engine goes into the cool down phase and stop. So during the cool down phase without high load, so minimum load, or only 1500 RPM, we can, and at the point when it stops, we can listen to the noise of the centrifugal filter and of the oil mass separator. I will come back to the 2 points later to that, but you can listen if there is any noise, vibration or anything else on the two cleaning systems. The centrifugal filter is to clean the oil, and the oil mass separator actually is to get the oil out of the oil fork and bring it back into the engine. So here we have at number 7, we have here on the side of the engine the centrifugal filter, and in front we have the oil mass separator, and here number 15 we have the crankcase breather. So here a little bit more in detail. These 3 pictures here shows us the centrifugal filter. So the centrifugal filter sits in this housing. This is the filter element. We can take it out of the housing and open the filter element so that we have separate parts. And inside of the rotor, there will be all the dirt through the turning speed of the centrifugal filter. We will get all the small particle of dirt and bad oil to the outside or the inside wall of the centrifugal filter, what must be cleaned properly to ensure that the filter is working nicely. Then we have here the oil mass separator. These 2 parts here. This is a drawing with the filter element inside, and then we have here the crankcase breather.